Today we are going to talk about quadratic functions and their graphs, and we're going to talk about the forms being in just the standard, well, I say standard, what you normally see, ax squared plus bx plus c, and also the standard form, which is what we're going to deal with right now. So here we go, folks. All right, let's just kind of get a handle on this. Here I have two quadratics. Remember, quadratics are, the graphs of a quadratic is a parabola. One of these is opening up, one is opening down. So a little information here. The axis of symmetry is that line that runs right straight through the center of our parabola. And of course, in this case, because we're talking about functions, it's always going to be in the form x equals something, x equals 3, x equals 4, and that's where it goes through the x-axis, and it will always be a vertical line. So that's our axis of symmetry, and you can spin the parabola around on this and find reflections of points. Okay, the vertex of an upward pointing, or a parabola that is opening upward is going to be a minimum. That's the lowest point on the graph. And also, if it opens down, then the vertex is going to represent a maximum. This is in the form f of x equals ax squared plus bx plus c for now. And we know that if a is greater than 0, that it opens up, the parabola opens upward. And if a is less than 0, then it opens down. This is all review for you. You already know all of this, I hope. Okay, so let's look at the standard form. The standard form is going to be a times the quantity x minus h, the quantity squared, plus k. And in this case, the vertex is hk. Now notice that it goes backwards to what you would think, because it's x minus h. But if it's x minus h, in order for that to be you ignore that negative. It's the h that we're talking about. And of course, if it was x plus h, that would mean it was x minus h. So if it's x minus h, it's going to be, the x coordinate will be h, and then the y coordinate will be k. We talk about, in standard form, we talk about the parent function, and we've been through this with sine and cosine, where you have a normal sine curve, and what happens if you make it 2 sine, and what happens if you make it 2 sine, or sine 2x. So we're going to compare everything to the parent function, and the parent function is f of x equals x squared. That means that h and k are both 0, the vertex is at 0, and the size, or the width of the graph is just what we call normal, where a equals 1. Okay, now if we have a is greater than 1, right now we're still going to be centered at the origin, but now we're going to have a skinnier graph. If we have a is greater than 1, if we have a is 1, 1 and 1/2, 2, 3, the higher the number, the skinnier the graph. On the other hand, if we have a number between 0 and 1, we're going to have a much wider opening graph. Okay, and if we turn them upside down, you're going to have the same thing, except now a is just going to be negative 1. Turn this upside down, a is going to be less than negative 1. And if we turn this upside down, it's going to lie between negative 1 and 0. That just kind of gives you an idea of where we stand here. If we want to graph a quadratic in standard form, and the standard form once again is f of x equals a times the quantity x minus h squared plus k, where hk is the vertex, and a cannot equal 0. If a is 0, all of a sudden we just have a linear equation. Okay? It is a parabola. Any quadratic is graphed as a parabola. The vertex is at hk. The parabola has symmetry about x equals h. That's right, if you draw the line right through the vertex, the x-coordinate of the vertex is h, so it would be x equals h. If a is greater than 0, it's going to open up. If a is less than 0, it opens down, just like with our standard quadratic form. If a is greater than 1, it's going to be skinnier. If a is between 0 and 1, it's going to be flatter. Okay, let's talk about steps to graphing in standard form. And I'm going to suggest that you write these down and keep them by you as you're working your way through your examples, through your checkpoints, and then through your homework. So the first thing is we have to decide, is this going to open up or down, just to give us an idea of which direction it's going to go. Then we're going to identify the vertex. And then we're going to find the x-intercepts. And what that means is solve the equation for x. Solve the equation for x. X-intercepts are also called roots or solutions, which means you're going to set the equation equal to 0 and solve. Okay, then we want to find the y-intercept. Well, the y-intercept is where x equals 0. So you're going to plug 0 in for x and find out what your answer is for your f of x. Then you want to plot the vertex, the roots, the intercepts, and then use the axis of symmetry to reflect some points. You don't have to have the coordinate of a point to know where that point is. If you have a point that is 3 units away on the right-hand side of the axis of symmetry, this reflection point is going to be 3 units away on the left-hand side. We'll do an example of that. Okay, so here's our first example. We want to graph f of x equals minus 2 times the quantity x minus 3 squared plus 8. Step 1, we know this opens down, and the reason we know it opens down is because we have a negative out in front of our a term. All right, the next thing, the vertex is 3, 8. And we get this from our h and k values, and we're going to plot that 3, 8 on our graph. Okay, the next thing, we want to find the roots. So we're going to set the equation equal to 0, and we can't just factor, we have to expand the perfect square, the x minus 3, and then multiply it by negative 2, and then add 8, which will give us minus 2x squared plus 12x minus 18 plus 8, and that gives us minus 2x squared plus 12x minus 10. I'm going to divide by negative 2, so I have x squared minus 6x plus 5. This gives me x minus 5 and x minus 1, so my roots are 1 and 5. So I'm going to plot those points, 1 and 5. Okay? Next, let's find the y-intercept. If I plug 0 in for x, then I have minus 2 times 9 plus 8, which is going to give me I'm sorry, I kind of lost my place here for a second. Oh yes, plot the point way down at the bottom, okay, which is, that's going to be minus 10 right here, in case you can't see it. All right, now I put in my axis of symmetry, and if this is 1, 2, 3 to the left of my axis of symmetry, my other point is going to be 1, 2, 3 to the right of the axis of symmetry, which is going to be right about there. I can make that little point. So now I have my 5 points. Can you see the 5 points? And I'm going to connect them in a smooth curve, which will give me, the axis of symmetry is x equals 3. So there's my very messy looking parabola, that you get the point. Okay, so there's my five points, and I connect them. Okay, so stop now and do checkpoint number 1. Make sure that you draw the graph. Okay, example number 2, we want to graph f of x equals x plus 3 the quantity squared plus 1. So we know that it opens up and the vertex is minus 3, 1. So I'm going to plot my minus 3, 1 right here. Oops. Okay, just lost it. Plot my minus 3, 1. All right, the next thing I want to do is go ahead and put in my axis of symmetry, which is a vertical line that goes through negative 3. And then I want to set my equation equal to 0 to find the roots. So here I have done this with x squared plus 6x plus 10. So I know that I'm going to have a real tough time factoring this. And the reason for it is because if I remember, I use my discriminant, and this is going to be equal to -4. I can't take the square root of -4, so what that means is it doesn't cross the x-axis. This stands to reason because our vertex is at -3, 1, and it opens upward. If it opens up and my vertex is above the x-axis, then it's not going to cross the x-axis. So there's my little thing that you need to think about that on all the problems that you do. Okay, so now I'm going to find out what my y-intercept is. I set x equal to 0 and I get 10. So I can plot my point 10 here, and I also know that it is the same distance on the other side, 3 over on this side, 3 over on that side, so there's my other point. Now I only have 3 points, so it's going to be hard to draw a smooth line. So I want to choose another one. I'm going to choose x equals -1. And the reason I'm going to choose x equals -1 is that's between 0 and -3. So the f of -1 is equal to 5. There's that point, and once again I know that I'm 2 away from the axis, so I have to be 2 away over on this side. So there's my 5 points, and I can draw my graph. Did a great job of that again too, didn't I? Looks like somebody sat on it. Okay, so do checkpoint number 2, and we're done. See you around, folks.